Okay, so in previous section we have understood the Shannon-Fano encoding algorithm, which is the variable length coding algorithm, which follows the conditions of prefix coding. Now there is one more algorithm which we can use for the variable length coding implementation of source encoding technique, that is called as Huffman encoding algorithm. Let us try to understand how we can implement this Hapman encoding algorithm. What is the algorithm? First, we'll try to understand the steps of the algorithm, and then we will see its implementation by going through one typical example for Hapman encoding algorithm. So let us first try to understand what are the steps for the implementation of Hapman encoding algorithm. Step number one is very similar to the step number one of Shannon-Fano coding algorithm, where you have to arrange the symbols in decreasing order of probability. So here also similar to Shannon-Fano, in Huffman also we have to arrange all the probability symbols in the decreasing order. Then step number two, we have to combine the lowest two elements, and we have to assign binary 0 and 1 to two lowest symbols. Step number three, we have to combine the lowest symbols into one symbol with probability equal to sum of two original probabilities, and this list of the symbols will get reduced by 1. You have to carry forward the sum of two symbols at the bottom into the next line, where this the sum will get replaced by a single symbol, and the symbols in the vertical column will get reduced by 1. You have to repeat step number 1, 2 and 3 until you will have only one member in the last group. Once again, I'll repeat the steps. Step number one, you have to arrange all the symbols in decreasing order of probability, like what we do in step number one for Shannon-Fano encoding algorithm. Step number two, you have to focus on two lowest symbols, where you have to club these two lowest symbols and assign the binary 0 and 1 to these two lowest symbols. Step number three, you have to do the sum of these two original probabilities, two lowest symbol probabilities, and you have to carry forward this sum as a single element in the next column, so that the next column will have number of symbols reduced by 1. You have to repeat step number 1, 2 and 3, that is arranging symbols in decreasing order, combining lowest two symbols, assigning them binary 0 and 1, and summing them and carry forward this sum to the next step, so that in every step you will find that the number of symbols will get reduced by 1, and in the end there will be only one member in the column, and your process will get stopped for the implementation of Hapman encoding algorithm. I hope the steps are clear, and we will try to understand the implementations of these steps by going through a simple example of Huffman encoding algorithm. If you if you have noted down these particular steps, now we'll go to the example of Huffman coding algorithm. Now the example says that a discrete memoryless
लिहायचं राहिलं
source. Yes.
टिप्स लिहायचे राहिले होते.
Okay, you can just take a screenshot of this particular steps. Okay, I will explain first the example, because unless and until I'm not going to explain you this example, you will not understand what is written here. We will come back to these steps while understanding the example. So, example of Huffman coding. A source contains 6 symbols with probability 0.4, 0.3, 0.1, 0.1, 0.06 and 0.04. So there are 6 symbols with probabilities mentioned here. We need to ensure that the sum of their probabilities is always equal to 1. So if I add them together, it is 0.4 plus 0.3, 0.7, 0.8, 0.9, and total sum will be equal to 1. So these are the probabilities of the symbols given. Now as per the steps, step number 1, arrange symbols in decreasing order of probability. Arrange symbols in decreasing order of probability. So we'll observe that we have already organized this particular symbols in the decreasing order of the probability. So zero point 0.4 is on the top and 0.04 is at the lowest. So the probabilities are arranged in the decreasing order. Step number 2. Step number 2, assign 0 and 1 to two lowest symbols. So now I need to focus on two lowest symbols, that is 0.06 and 0.04. To these two lowest symbols, what I have to do, I have to assign binary 0 to the upper symbol and binary 1 to the lower symbol. That is my step number 2. Once again, I'll repeat. I have arranged all the probabilities in the descending order. I have taken two lowest probability symbols combined together. Upper part, upper symbol, I have assigned binary 0. Lower symbol, I have assigned binary 1. Now, step number 3. Combine lowest symbols into one symbol with probability equal to sum of two original probabilities. It means whatever the thing that I have combined together and I have assigned 0 and 1, now I have to sum them together. What is the sum of 0.06 and 0.04? This is going to be 0.1, and this sum, it should get carried forward into the next column. So now I'm preparing a next column. This sum I have to carry forward into the next column. So my next column will be 0.4, this 0.4 as it is, this 0.3 as it is, this 0.1 as it is, this 0.1 as it is, and the sum of these two values is also 0.1. It has been carried forwarded into the next column. Now here column 2 contains one less element compared to column number 1. Therefore, we have to now focus on stage 1, that is column number 2. Once again, we have to arrange them in descending order. So by arranging them in descending order, I am going to get 0.4, 0.3 as it is. Here there is a problem. The problem is that this sum is 0.1 and we have two earlier 0.1 values. So there are two options. This 0.1 may go to the end of this particular list, or it may go to the third number of this particular list. So the conventional way is to take this new value at the lower end so that you will get the maximum efficiency of that particular code. So therefore, in stage 2, we are carry forwarding the sum of these last two elements to the last end, and we have already organized them in the descending order. I hope the things are clear. Now same process I have to repeat for next column. So in next process, I have to once again focus on last two elements. I have to combine last two elements. I have to assign binary 0 to the upper element, binary 1 to the lower element, and the sum of these last two elements I have to carry forward into the next column. I hope the things are clear. Now the next column will have this 0.4 as it is, this 0.3 as it is, but 0.1 plus 0.1 is 0.2, right? And whenever this 0.2, if I arrange it in descending order, this 0.2 will come at this location and this 0.1 will go down because this column is once again arranged in descending order. I will repeat this step. Last two elements 0.1 and 0.1 I combine together. The sum is 0.2. 0.2 is carried forward into the next column, but after arranging them in descending order, this 0.4 will be as it is, this 0.3 will be as it is, 0.2 will be replaced here, and this 0.1 will go on the bottom of the column. Once again I have to repeat the same process till I get single element into the column. So once again, my focus will be on last two elements. I will assign binary 0 to the upper element, binary 1 to the lower element. Okay. And then the sum of these two is 0.3 will be carried forward into the next column, 0.4 as it is, 0.3 as it is, and this 0.3 at the lower end. Same process I will repeat for last two elements, 0.3 and 0.3. Binary 0 is assigned to the upper part, binary 1 is assigned to the lower part. This same will be carried forward into the next column. So 0.6 and this 0.4 will come down. Last two elements are also combined. 0 is assigned to the upper part, 1 is assigned to the lower part, and their sum 1 will be carried forward into the next column, which is the last column that I have not considered here for the analysis. So this is what the way with which we have assigned the zeros and ones to the lower elements of every column, and we have carried forward their sum into the next column. I hope the first 2-3 steps are very clear for the implementation. Now the most important thing that I need to focus is to go on collecting the code word for each and every symbol. So how I'm going to connect this particular code word? So I will focus the code word for 0.4. Look at 0.4. If I'm starting here, I have never found any binary 0 or 1. So there is no code for stage 1. Here also there is no code for 0.4. Here also there is no code for 0.4. Here also there is no code for 0.4. But this 0.4, when goes it here at this particular point, I found that the code for 0.4 is binary 1. Therefore, in my table, I got the code for 0.4 as binary 1. I have to follow these arrow lines, 0.4 to 0.4, 0.4 to 0.4, 0.4 to 0.4, and 0.4 to 0.4. Here for this 0.4, I got binary 1. Therefore, the code for 0.4 is binary 1. Same thing, now I'll do it for second symbol, that is 0.3. For 0.3 there is no code. Here 0.3 there is no code. Here 0.3 there is no code. Here 0.3 I got 0. Then it has been combined and shifted here to 0.6. Here also I got 0. So the code for 0.3 is 0, 0. Basically, we have to go from stage 4 to stage 1 in the reverse order. But I am following the forward order. So my final code will be in the reverse order. So here 0, 0, its reverse order is also going to be 0, 0. So it will remain same for 0.3. Now let us look at the case for 0.1, which is a little bit tricky. Okay, I'll just take annotate so that you will understand how we are proceeding for this 0.1. From this 0.1, I have carried forward to this 0.1. There is no code. From this 0.1, I came down to this 0.1. I have collected binary 1 here, right? So binary 1 is present here. Then this has been combined together, carry forward here. Here I got this binary 1. So this binary 1 is present here. Then this has been combined and carry forward to 0.6. Here I got another binary 0. This binary 0 is appended over here. In my basic process, I have to go from stage 4 to stage 1 back. But as I'm forwarding using a forward method, whatever the code that I got 110, I have to reverse this code, so it will become 011 as the final code word for 0.1. I hope the things are cleared. I'm following the method of forward pass, creating a reverse code. Similarly, if I want to create a code word, let us for next particular 0.1, then this 0.1 is being carried forward here. This 0.1 has given me binary 0, so I observed here binary 0. This is combined together and is been shifted to 0.2. Here I got code to be binary 0, so here I'm having binary 0. This is combined together and carry forward here at 0.3. Here I got binary 1. This has been, so this is binary 1. This has been combined and carry forward to 0.6. Here I got binary 0. So this is 0. and in the reverse order it will be 0 1 0 0. So 0 1 0 0 will be the final code for point 1. I hope the things are clear. Once again, now I will do it for another 0.06. So for 0.06, now I have started once again. 0.06 I created 0, so I got 0 here. Then it has been combined and carry forward here. I got here 1, so 1 is present here. Then it is combined and has been carried forward here, so I got 0 here, so I got 0 here. Then it is combined and carry forwarded here, I received 1 here, so I got 1 here. This is combined and carry forward here, I got 0, so that has been 0 here. And finally the code is in the reverse order, so I got 0 1 0 1 0. So 0 1 0 1 0 is the code that I'm getting here for 0.06. And same procedure if I follow for 0.04, the only difference is here, instead of going to 0, 0.04 is now going to 1, and the rest of the code is going to remain same because it follows the same path 1 1 0 1 and 0. So 1 1 0 1 0 in the reverse order 0 1 0 1 1. So this is the way how we can generate the code word for each and every symbol by following a forward path and reversing the code in the reverse path. Many of the books, they try to explain the Huffman code going from stage number 4 back to the original stage, but it becomes very difficult in tracing the code word in the reverse order. That's why this is the simplest method. Go on forward way and reverse the code so that you will get the final code word for Hapman coding. Similarly, for this particular code word, you may calculate the entropy by using these probability values. You have code word, find out the average code word length and calculate the efficiency of Hapman coding algorithm. So that efficiency we will find out is pretty much better as compared to Shannon-Fano coding algorithm. I hope I tried to explain the algorithm in the simplest way by taking one example, and every step I try to explain you for the generation of the code words for the Huffman coding algorithm.